Hello students, in this video lecture we are going to discuss about the different data registers which are used in the case of the LPC 2148. So if you see the again user manual of the LPC 2148, so every channel has its own dedicated data registers. For example, for the first channel it is ADDR0, okay, then it is ADDR1 like this. So we find 8 different data register which are with respect to the each channel. So what is the use of that these data registers of the LPC tone forest? So that can be used to read the results of the analog to digital conversion. Also it will check the whether the current conversion is done or not, or means current conversion is completed or not. So again, if you see these data registers of the analog to digital converter, it is a 32-bit register or 32-bit value register. The first, if you see the bit pattern here, the first bits are the reserved one which are not usable for the user or the programmer, and the main part is here 6, the bit from 6 to 15. Okay, so these bits are used for the result part. The 13th number means 30 number bit is used for the overrun, and the 31 bit is used for the yes, whether the analog to digital conversion completes or not. So we start with the done bit. So the done bit, it is a bit number 31. So this bit is set to the one when the analog to digital conversion is completed. For accurate result, you need to wait until this value is equal to 1, okay, before the reading the result bits. It is clear when the register is read, okay, fine. So this is a done bit. Overrun the bit number 30. So this bit equal to 1 if the results of the one or more conversion were lost when we are in the burst mode. Okay, so if we are selecting the burst mode, and we are basically your A to D converter accessing the number of channels of the your ADC, right? And so it converts continuously the analog value or the analog data which is sent on the different channels. So when we are in the burst mode, okay, so this overrun basically used if the results of the one or more conversion were lost. Next, the last one is the result. So if done equal to 1, okay, so these 10 bits will contain a binary number representing the results of our analog to digital conversion. So it works by measuring the voltage on the analog input pin divided by the voltage on the V reference pin. It is always remember. So uh, it measures only when the voltage on the analog input pin divided by the voltage on the V reference pin. So 0 means that the voltage on the analog input pin was less than equal to the close to the ground, means your VSSA. Okay, and it indicates that the voltage on the analog input pin was close to or equal to greater than the voltage on the V reference pin. Okay, when the value we get as 0x3FF. Okay, so result, when we talk about the result, okay, here when done equal to 1, so I repeat again, so 0 in the field indicates that the voltage on the analog pin was less than or equal to close to the ground pin of the analog to digital converter VSSA, and when it gets the value like the 0x3, if it indicates that the yes, the voltage on that particular pin, which pin we are connected, okay, is close or equal to or greater than a V reference pin, means it is 3.3 volt normally, and anything value which are in between this means the ground value means 0 value or the V reference means 3.3 volt, okay, it will be treated as string will be written as the 10-bit number, means 0 to 1023. Okay, so it is a your yes data register. Fine. Same for same bits can be found in the global data registers of these LPC2148. Okay, if you see that part, global data register. So okay, this is a global start register. I think it is a right. So it is a global data register. Okay, only thing is again global data register. We it is a one of the feature for the LPC2148. We already know. So it can be used to uh, globally start both the converters, right? AD0 and AD1, because we can use the bus mode also. Only thing here, when we compare the analog to digital global data register and the AV channel ADDR register, mean data registers. Okay, the thing is it having only the CHN bit, 2 bits. Okay, symbol is CHN. So 25, 24, 25, and 26. These 3 bits are used to for the contain the channel information. Okay, so these bits contain the channel from which the result bits were converted. Okay, the remaining bits are the same. We know for the data register it is 31, 31 is the done, and result we get into the 16 to 15 number bits. Okay, so this is about the analog to digital global data register and the data register. Thank you.